Hello and welcome to my overview of the TI-84 calculator, which is also going to serve as a review for the TI-83 calculator. Give me a moment, I'm going to switch over to the sharing screen so you can see the calculators. So right here we see the TI-84 Plus Silver Edition. It's going to be pretty much exact same as the TI-84 without Plus or without Edition. Anyone in the TI-84 family of calculators. Here is the TI-83 Plus. Again, anything in the TI-83 family of calculators will be good to go. Here is my cell phone where I've downloaded the free, it's an Android, so I've downloaded a free emulator, the Wabbit emulator, and you can search for it, and it's again free. And I've downloaded the TI-84 Plus C Silver Edition. C stands for color, which is just kind of nice when you're graphing multiple things to be able to differentiate between them. And I mentioned this just so you know that there is a free option for an Android phone. There are fairly inexpensive options for Apple that you can search for. Some are more or less similar to this calculator. And I have the other video for the TI-89. And the TI-89 doesn't have nearly as many good options for emulators. The actual calculator is going to be the one you'll most likely end up wanting to have. One of the disadvantages of a cell phone, of course, is if you were going to be using this in a future class on ground where your teacher says you can use it during part of a test or even an entire test, you obviously couldn't be using your cell phone. However, there are often ways to borrow from different programs on campus, such as Mesa, where you can get one to borrow during the semester. So this is just a brief introduction to some of the key features of the calculator. So to turn it on, there's this on button right here. Same on this one. And the main things I want you guys to recognize is that this part of the calculator is the same as a normal four-function calculator. This part is not anything new. So if you want to do like traditional multiplication, again, you have it on, you can see a little blinking cursor there. And let's say you want to do 8 times 10. Times will look like a asterisk on the screen. And if you want to do 8 divided by 10, for example, the divided by is the traditional symbol here, but it looks like a division slash on the screen. And you can see that I can keep adding things on. There's it's called a stack, and you can keep going. On the left side is what you've entered, the right side is the evaluation of it, what the value is of it. And you can see that this turned it to the decimal version. 8 divided by 10 is the same as 8/10, which is 8 in the 10th spot, so 8/10 as a decimal. If you wanted to convert it to a fraction in lowest terms, you can hit the math button right here. And this is one of the functions of your calculator, and a menu appears, and in the main math section you can see that the first option is an arrow to fraction, which means it's going to convert it to a fraction in lowest terms. So I hit enter to select it, and I hit enter again to perform that function. So it'll convert it to a fraction in lowest terms. 8 divided by 10, 8/10 is the same as 4/5. Dividing both numerator and denominator by 2, you can see that those are equivalent. If you want to go from a fraction to a decimal, well, you just type it in, like 8 divided by 9, there's the fraction. The decimal will be hitting enter. One other thing, since we're talking about fractions and decimals and things like that, there is a mode button, and you can see here that you can float the number of decimals, which is what I recommend, or you can say you only want it to go to the nearest tenths or hundredths or thousands, etc., by selecting how many decimal points it goes to. There's also the scientific mode if you want it to be in scientific notation. radian and degree matters more in a trig course or a geometry course. We're going to be doing functions, so keep it in that format. Next page. Math print just makes it look a little prettier, and you'll see when I get to exponents, I'll show you the math type version, and then I'll show you the classic version. You can also see the numerator divided by a denominator format for the fractions. And then this one would be having the like 5 and 2/7, for example, would be 5 and then 2/7. Answers in auto, which is what we had, or you can always have it be a decimal or always be a fraction. Generally, auto is good because you can always convert it doing math, enter from a decimal to a fraction. And other instances, it really is only going to be appropriate to do one or the others. But do note that there is an option to change it how you want your answer format to be on this second page of the mode window. The next one says, you know what, the rest of these really don't pertain too much. You can see I haven't changed the date or time for my calculator, but I'm not using its calendar or clock. Generally, I just use my cell phone for that, but it can be used in that way. So let's quit this and get out of this menu. To get out of a menu or a window, you can hit the second and the mode button, because above the mode is the word quit. So this blue allows you to access all the blue options, all the functions that are written in blue above the button. You just hit the second and then the button that's underneath to access that. So I'm going to hit second, and you can see I have this up arrow, which means I've hit the second button, and then mode to quit that menu. If you want to clear your screen because it's just too messy for you and you just want a clean slate, clear will clear the screen. Let's talk about some of the math things now. So we already talked about the fact that you can obviously divide and multiply and subtract and add. Please note that this is an operation subtract symbol. You can see it probably better here. Subtraction symbol, versus down here, it is the negative. It makes it a negative. So if I wanted to do -8, I'm getting the light a little bit, -8 plus 3, I would be using this negative here. If I had said negative, what it actually does is it takes your prior answer and it subtracts. So that's not negative. Don't think of this as negative. Think of this as subtract or minus. Subtracting. It'll take the prior answer and subtract. So if I wanted the prior answer, -5, and I wanted to subtract 3, I could say -3 from that. And I get -8. So be careful with the subtraction versus the negative. A couple other things I want us to be familiar with as far as just the basic calculations is the square, to square or cube or raise anything to a power, you can use this caret symbol. It's above the 6 on your computer keyboard. It's called a caret symbol. It's right here, and it raises something to a power. So if I wanted to do 5 squared, I would hit 5. Then I'd hit the caret, and then I'd hit 2. And you'll notice there's a blinking box up there, an entry answer box. And let's go ahead and say enter. Now, if I didn't want 5 squared, I wanted 6 squared, I could either retype it as 6 caret 2, or I could scroll up and up to it, hit enter once it's selected, and it'll retype it, and then I can change it by using the arrows to 6 squared. I want to mention that caret is great for other powers, so like to the 3rd power. There is a special shortcut button for squaring. So X is like what you've entered being squared. It doesn't actually mean I'll have an X. So if I wanted to square 8, I could just hit 8 squared with the special square button. Squares and square roots are inverses. That's why they share a button. Just like you'll find out later in this course. Exponential with a base 10 is the inverse to the common log rhythm function. You have here e to some power, the exponential with the base e, and the natural log are inverses. And so a lot of these buttons are near each other when they're related to each other. All right, so another cool thing you can do is select a prior answer and then do something to it, which is great for like order of operations or things like that. The other option for you, aside from just adding, subtracting, multiplying, and dividing to the prior answers, if you want to use the prior answer, just the one before, not many before, but the right before it, you can hit second answer. So the little subtraction thing in blue has A and S for answer. So it'll take the prior answer, 120, and let's just add 1 to it. All right, so I'm going to clear the screen again. So we talked about exponents. Squaring has a shortcut here. Any other power, you'd want to use the caret symbol. If I want to do the square root of something, I'd hit second and the square button to get the square root button, and then I'd type it in. Let's say I want the square root of, actually let's go back. So I can use the back arrow to overwrite. I can also hit the delete to delete a value. Square root of 25, for example, enter, is 5. If I do the square root of 50, it's going to give me the decimal approximation. We'll learn later in this course how to simplify root 50 so it's still exact. And so whenever you see this, this isn't the answer I'm going to want. This is fine because 5 isn't exact. This is an approximation. All right, so if I wanted to do something that involved parentheses, I have those here. A lot of these other functions, once we get to using them for an assignment, I will go through how to use them for that assignment or share a video that goes through how to use it. A couple other cool things to note is that later in this course is in the math, I showed you the fraction. There's also a cube root, because we're going to be dealing with cubes later in this course, or an x root, so a 4th, 5th, 6th root. There's also a cubing shortcut that's sort of shortcutty, but again, I think just raising it to the 3rd power is probably just as quick as doing math and scrolling down. And speaking of scrolling down, you can also hit the number associated with the function. So I can just hit 5 and it will jump right to 5. So I mentioned that there's that classic and then the math display. So here on the 83, this has an older operating system, so it's not the pretty. If I do a caret, it doesn't have the blinking box up at the top for the exponent. It will show the caret symbol. So that's kind of one of the main differences. Sometimes the 84, if you don't have the updated operating system installed on it, it might also have the arrow. All right. All right, so this is a graphing calculator. So let's also talk about the graphing functions of it. So the bar up at the top here is really the location for most of what you're going to be doing in terms of the graphing stuff. So there's y equals window, zoom, trace, and graph. And if you hit the second button, you can get to stat plot, table set, format, calculate, or calc, and table. So I'll leave this down here just so you can see the same things because the screen, it's a little bit harder to read those. So let's figure out how to graph. So if I want to graph something like let me clear out of these. Look, I have these from a prior problem. I'm just going to hit clear to clear them and clear. So I went down and then clear. All right, so I want to enter the equation 2x, so x, your variable is right here, plus 1. And I want to graph that. So it's selected here, the equal sign is selected here, so it's going to graph that. You can actually turn off graphs if you have many of them and you only want one at a time. You can turn them on and off by hitting the enter over the equal sign. Oops, I did the shading, which is for inequalities. It was too far over. So I think I've scrolled too far. Let's see. There, this is standard line. What did I have? I had 2x plus 1. All right, so again, since it's highlighted, it will graph it when I hit graph. And the little arrows up here, that the cursor was moving, meaning it was working. Sometimes you'll see like the word busy show up. I think that's actually on the 89 that you see the word busy. So this is the graph of the line 2x plus 1. You can see the y-intercept at 1 and the slope is 2. Now, depending on your window, your graph maybe be a little bit deceiving in terms of its steepness or lack thereof. One of the things to note is that, let's say I did a parabola. Let me go ahead and deselect this or just clear it out. I'll just clear it out. If I wanted to do a parabola, x squared plus 5x plus, let's say, 12, enter. If I hit graph, this parabola is, I've got part of it there, at least some of it showing. And if I had done another parabola, maybe none of it would be showing on this window because this window is set to be, and if I look at the window, it's set to be this random window here. And normally, if I hit the zoom, normally standard is a good place to start. And standard means that the window is going from -10 to 10 in the x direction, the horizontal direction. And each tick mark is 1. And it's going from -10 to +10 with each tick mark being 1 unit in the y direction, the vertical direction. So when I graph, I'm going from -10 to 10, and each tick mark is 1 unit. -10 to 10, each tick mark is 1 unit. If I wanted to have this be a little bit more centered in my graph, or let's say it was off the window and I wanted to view it, you can change the window in a couple ways. One, if you kind of know where you're going, you can go into window and say, well, I wanted more in the Y. I wanted it to be higher up, so I can change the Y max to be much bigger. Oops, bigger, 20, and hit graph. And so you can see that now I have 20 tick marks here. I don't need as much in the X direction, so maybe I'll change the X to be less big, so maybe just a 5. So you can manually adjust it. Sometimes it's really far off your graph, and you don't even have a clue as to how to get it to show. In that case, zoom out can be helpful, but the even more helpful one is if you scroll all the way down to zoom fit. And for those of you going on to stats next, Zoom Stat will be a huge go-to place. Or even in pre-calc, you might be using Zoom Stat. Okay, but Zoom Fit, there's all sorts of Zooms, and it depends what you have in your calculator. Some of you don't have those, but Zoom Fit we should all have. So if I hit enter, what it's doing is it's working. See that right there. And what it does is it makes your graph work so that it exits in the upper right hand corner, but includes, you know, all the key components. So we can actually see the vertex right there, the lowest point, and you know, maybe that's what you want. But sometimes, even though it really shows you the parabola, still maybe not really what you want. Maybe I want to calculate this and I want a little bit of space below. So you can always manually change it, but doing the Zoom Fit might give you a closer idea of where to have it centered. And maybe you're just like me, I don't really like these decimals. I'd rather just bring this to, instead of y min being 5, to it being 5.75, to it just being the lowest being then 6 or 10, actually 5, but you wanted to incorporate it. Y max, so you might want to go a little bit higher. You don't want to end at 62, or maybe you don't care about that full height. You just want to focus on the vertex. Maybe you can even go lower. Let's do 50, and you can count by 5s maybe. Okay, so if I wanted to calculate this and I wanted to have some space below it, I would need to go much lower in the y direction. I'm pretty good on the x direction, so let me change the window in the y direction. So y min, I want to go much lower. So let me go maybe to -10 so I can really see that vertex. And I don't need to go nearly as high, so maybe I'll go to just 30. So as you're learning more about functions, you're going to be playing around with that. Once you get a little more comfortable with functions and windows and all that, you're going to, I hit 3 instead of 30. You're going to be able to do this a lot quicker. All right, so some other things with this, you had the y equals where you entered your function. It had to be y equals format. So if you have a line that's in standard form, you have to first rewrite it into y equals format. Or if you have a circle or any other shape that isn't generally solved y equals, you need to do the arithmetic or have your calculator do the arithmetic to convert it into y equals format. The next thing I want to show you, so that's a window in Zoom, is the table. So second graph gets you the table. So this is you having an input of 0, an x of 0, and the y would be 12. So this is another way you can also evaluate functions at certain values. You just type it in and then have the x. And you can scroll up and down to see different inputs and their corresponding outputs. That's where this table set also comes in. Second table set, you can always have it start at like -3, count by ones, and it'll be -3, and I believe it goes up to 3 then. So you can see it went straight to -3 to 3. That's kind of a standard window. But later on in like pre-calc and calculus especially, it's nice to be able to not necessarily have -3 to 3 or even 0 to 6 or whatever it might be, but you might want to have it just find certain ones that you ask for, and so that's what the ask is. So instead of automatically having this table counting by ones, you can ask. So I'm going to change it to ask just to show you that. So if we go back to the table, second graph getting in the table, I can input 5 and it'll evaluate the function of 5, or I can input negative, remember negative is down here, -3, and it will give me the output. And so that can be really handy. All right, so let me go back to this graph, and I can just hit graph, or I can hit quit and then hit graph, or whatever you feel comfortable with. If I am trying to find, let's say, the vertex of this, I could trace and try to get close. You can see it's tracing along the curve. Get close to that minimum. But you can see it kind of jumps to different pixels. So depending on how closely zoomed in you are, you can become more or less accurate to the exact lowest point. But this is really to do it as an approximation, because again, it just kind of jumps along and it may not actually find the exact location. So same with the y-intercept. You know, you might be able to get right on it, or it might pass by. You should recognize from prior courses, if x is 0, you get your y-intercept, and if x is 0 in your function, your y-intercept is 12, and you can see I'm getting not quite to x is 0. I go just below 0 and just above 0, and you can see on the y I'm going just below 12 and just above 12. I'm not actually getting the exact one. So to get exact values, you want to use the calculate feature. The calculate feature has a couple that we're going to be using in this course, really the first 5. You can calculate a specific value. So when x is 0, that would be your y-intercept, by the way, you get a y of 12. X is 0, y is 12. So I just hit 0 and enter, and then the corresponding y showed up. Calculate, let's say I want to find the value when x is -4. And it jumps to where x is -4, and it finds the corresponding y value of 8. Remember, these were counting by 5. What were they counting by? 5s, I thought. Yeah, the y scale is 5. So let me get back to the calculate value. I said -4. So it is just below the 10, 8 is the exact value. So that's the value part of the calculate function. There's the 0. 0 is another word for the x-intercepts. So we really don't have any zeros here. So I can't really use that function. I'll do one in a moment where you can see the 0 function. The minimum. This one does have a minimum right around there. So you just follow the prompts. It says left bound. That means the boundary that you want it to look at. So you want to kind of tell them where to be searching for the lowest. So the left side, I'm already on the left, but I can use my arrows to move around. So as long as I'm anywhere on the left, I can hit enter to select it. Then it shifts to the next prompt, right bound. So I can arrow over to the right side, near where I'm looking for, but anywhere on the right, near where you're looking, hit enter. And so it's going to look in between here and here for the x and the corresponding y that is at the minimum. And there it is, -2.5. This is a rounding error. It's really -2.5 if you calculated it. That's one of the things about calculators. They can do a lot of work really quickly and easily for you rather than having to use like the vertex formula, but it also has some limitations with rounding or pixelation or some of the domain stuff. So in any case, -2.5, 5.75 is the minimum point, also known as the vertex for a parabola. Calculate, so again, second trace gets you calculate. You can also find an intersection. So what I'm going to do is find another equation to enter in here. And let's do x. Let's go back and change it to 2x minus 5. 2x minus 5. So now I'm going to graph both of these simultaneously because they're both selected. So if I hit graph, all right. So on this one, I want to find the x and y intercepts so I can show you the 0 function. So second calculate, let's do the 0. That finds the x-intercept. And I don't want it to be for this first one. So I hit the arrow, the down arrow, and you can see it's blinking right around here, but it's on the second line, and it tells you which line you're on. y2, the second one, and I can hit arrow over, and I want to say, well, on the left side of the 0, the intersection here, enter. Now I'm going to go to the right side. So mainly you're going to follow prompts. And so this is intersecting at 2.5 comma 0. Again, a y-intercept, when y is 0, you get the x-intercept. If you want to get the other one, you can do the value and put in a value of x is 0, and it will get you, oops, wrong function. There we go. I just hit arrow down. When x is 0, y is -5, which we hopefully recognize as the y-intercept. Again, plugging in 0 for x, following order of operations, we get -5. Graph again. So let's adjust this and find the intersection of a curve and a line, which is essentially finding the solution to a system. All right, so let's increase the slope to 8, and let's go like maybe +3. Let's see if that makes a nice problem. All right, so if I hit zoom, goodness, zoom, fit, it's gonna think, it's gonna widen out that x and y, and it's going to make it again so that your function here, it's making the line go through this corner and the parabola go through this corner. That one doesn't really intersect very well. Let me increase the steepness because the parabola gets steep pretty quickly because it's squaring. So y equals, let's go ahead and do like 15x plus 3. Let's see. It's still in a wonky random window. Oh, it's getting much closer to intersecting. It may even intersect, but let's make it where it's very clear. So let's increase the steepness so that the y-intercept is fine, but let's increase the steepness. So y equals, so to increase the steepness, we increase this. Let's make it just 25. Let's graph again. All right, so to calculate that intersection, we go to second calc, the trace button, go down to intersect or hit 5. It'll say first curve. Sure, that can be my first one. Hit enter. You can see I'm on the second curve. So yes, that is my second curve. That's just so that in case you have like 3 or 4 curves, you can pick which specific ones you want to find the intersection of. Guess just means go kind of near where the intersection that you want is, because sometimes things intersect in more than one place, and so you want to kind of indicate which one you're searching for. Hit enter, and it'll find it as an approximation because it's not a nice, pretty intersection. So that's another huge benefit of having technology, is that if you were doing this by hand, you would have had some fraction that would have been kind of probably a little bit cumbersome to work with. And then if you wanted to graph it, you'd have to then still evaluate it, get these, and then try to graph them. And so anyways, it's kind of nice when you don't have nice exact integers to have your calculator help you out. So the table, just again, because it's still an ask format, you might want to go back to auto because that'll be the standard situation. Hit enter, second mode to quit, and we'll still have that selected. So those are the main things I wanted to show you. We'll look a little bit more at the probability features later when we do binomial theorem, and we'll have the explanation point, which is the factorial. We'll again use cube root when we do our cubic and cube root information. And what else do I want to say about this? Here is the reciprocal function. raising something to a negative power. So if I did like 3 to the, oops, sorry, 3 to the negative 1, that's the same thing as 1 over 3 to the first. Using your rules of exponents, a negative exponent, you do the reciprocal, and so flip it to make it a positive exponent. So it's the same as 1 over 3 to the first, or 1/3, which is 0.33. Again, math, change it to a fraction if you want it in that format. There you go. A couple other buttons that we will be using later in this course, just so you can see them. Again, x squared, the square root, the caret, all the main operations, the enter or equals, the negative is very important, on and off obviously is important, the graphing ones here that we just did, delete can be helpful, mode, make sure you're kind of in the standard mode, and the quit button above it, math is helpful. The log we'll be using later in the course, and the natural log, and the blue 10 to the x power a little bit, and the x power as well. So if there's other things that are kind of missing from here, they may be in the catalog. You can see that the catalog second 0 shows you a list of all sorts of functions in alphabetical order. And let's say you wanted to do something that started with, I don't know, let's see, S. You could also use the alpha. Actually, I think it's already set to alpha. Let me just make sure. Yeah, alpha S. And you can see it'll go to the sample stuff and all the other S ones. So there's lots of different functions that this calculator can do. We are only going to scratch the surface. Again, to exit, second, and the mode button will give you quit. And then second and the on button will give you off. I hope you found that helpful.